Have you ever wondered what's running silently under your feet, carrying enormous amounts of electricity, but without you ever noticing it? Yes, I'm talking about underground cables. These cables are the hidden heroes of our power system. Unlike the overhead lines that we can see hanging on poles, underground cables remain buried, quietly ensuring that power reaches where it is needed. But what exactly makes them so special, and how are they designed? Let's take a closer look. An underground cable essentially consists of one or more conductors, each carefully covered with insulation and then protected by multiple layers. Now, the choice of a cable depends on its working voltage and service requirements. But before even putting one in the ground, the cable must satisfy some very important conditions. For example, the conductor should ideally be made of stranded copper or aluminum, because that improves conductivity and makes the cable flexible enough to carry more current. Imagine if it wasn't stranded. It would be stiff like a stick. And that's not what we want in an underground system. Also, the size of the conductor matters a lot. If it's too thin, it will overheat and drop voltage beyond limits. So, the right size is critical. The insulation thickness is another important factor. It has to be just right, so the cable can handle the designed voltage safely. And of course, since the cable has to be buried underground, it needs mechanical protection to withstand rough handling during installation. Finally, the materials chosen must be chemically stable so that the cable doesn't degrade over time due to soil, moisture, or other environmental conditions. Now, how about the construction of cables? If you've ever seen the cross-section of a 3-core underground cable, it looks like a fascinating layered cake of engineering. At the very center, we have the conductors. These can be tinned copper or aluminum, stranded to give flexibility. Each conductor is surrounded by insulation, which keeps them electrically separate. The insulation can be made from impregnated paper, varnished cambric, or rubber mineral compounds. Over this insulation, we have a metallic sheath, usually made of lead or aluminum. Why? Well, it's there to protect against moisture, gases, and even chemical attack from soil. Without this sheath, the insulation would quickly fail. On top of that comes the bedding, a fibrous layer like jute or Hessian tape, which protects the sheath from corrosion and also cushions it from the armoring layer. Then comes the armouring, usually steel wires or tapes, which gives mechanical strength. Just imagine, without armouring, the cable could easily get damaged during laying. Finally, we have the serving, another fibrous layer, which protects the armour from atmospheric conditions. All these layers together make the cable reliable and long-lasting. But of course, the heart of the cable lies in its insulating materials. Without good insulation, a cable is useless. The insulating material has to tick many boxes. It must have high insulation resistance, high dielectric strength, mechanical toughness, be non-hygroscopic, non-inflammable, chemically stable, and also cost-effective. Quite a long wish list, right? So what materials are actually used? Well, we have rubber, which comes from tropical trees or oil products. It has decent properties, but it absorbs moisture easily and can't handle high temperatures, so pure rubber isn't ideal. Then we have vulcanized India rubber, or VIR, which is basically rubber mixed with compounds like zinc oxide and sulfur. It has much better durability and water resistance, making it quite suitable for low and medium voltage. Another popular material is impregnated paper. This is made from specially treated pulp, soaked with compounds like paraffin. It's cheap, reliable, and offers great dielectric strength. That's why paper insulation is still widely used, though it does have the drawback of absorbing moisture. To handle this, paper-insulated cables are usually enclosed with metallic sheath. Then comes varnished cambric, which is basically a cotton cloth soaked with varnish and lapped around conductors. It's strong and flexible, but again, hygroscopic, so it needs metallic protection. And finally, we have PVC, polyvinyl chloride. This is a synthetic compound that's incredibly tough, chemically resistant, and stable over a wide temperature range. It's inert to oxygen, alkalis, and acids, making it perfect for harsh environments like chemical plants. For this reason, PVC cables are very common in domestic and industrial applications. So, underground cables may look like simple black wires from the outside, but now you know how much thought and engineering goes into making them safe, strong, and reliable. Tell me in the comments, If you had to choose one insulating material for cables in your city, which one would you prefer? PVC for toughness or paper for economy? Before we wrap up, don't forget to hit the like button if you found this explanation useful, share it with your friends who love electrical engineering, and of course, subscribe to the channel so you don't miss the next video. And if you'd like to support my work even further, check out the thanks button below the video or consider becoming a member through the join button. Your support means a lot and helps me bring more detailed content like this.